Hey guys, here's another lesson that I've created. This lesson is going to be about the periodic table. So let's get into it. So today we will be learning to identify what the periodic table is and learn to use it effectively. After this lesson, you will be able to understand the periodic table, use the periodic table to explain metals and non-metals, use the periodic table to help predict chemical reactions, understand reactivity, and know the history of the periodic table. You may also be able to use metals and non-metals. If you see here, you may also be able to use them in DT or engineering as a part of STEM. So this is a good topic to go over, not only science for this one. So what is this periodic table? That's the first thing we need to know. So you may be thinking, when this periodic table comes to mind, what is it? Well, this is a collection of elements. A table which has all the elements in it. Okay. It also has some extra information. We'll talk about that just in a minute. So these placement of these things, you may think, yeah, I can place them anywhere and they'll be fine. It's not that simple. The elements, they're placed in such a way that they give information about them. Okay, let's learn now what information they give. So the information they give is, if you see these lines, we can first look at periods. So these side numbers, these are the periods. They are the rows of the periodic table, and they tell you the number of electron shells. Okay, remember this. We'll just learn what electrons are and what electron shells are a bit later. But they tell you the number of electron shells. These top numbers, 1, 2, 3, 4, and so on, up to 0, you may think 0 is a bit odd. But the reason 0 is there, it can also be called group. These we call group numbers. Just to clarify, the reason 0 is there is that these have a special property. We'll just come on to that later. But this can also be called 8. Okay. But yeah, there is also, if you see these each square, that is one element. So each element has a specific information put into it. Like if you see beryllium right here, it has this number 9, which is the higher number in the thing. There's 9 and 4. The higher number we refer to as the atomic number. The lower number we refer to as the mass number. Not in like height, because sometimes they switch around. If you look at different periodic tables, they may be in different orders. So you always look at bigger numbers and shorter numbers. Okay. So as you see here, there's an element symbol. This H is an element symbol. So these element symbols are like short ways of writing the element. Like the whole element is hydrogen, the short way of writing is H. Just to shorten it, okay? One thing you might want to remember with this is that they're like two letters, like lithium right here, Li. Only the first letter is capital. The second letter is is lowercase. This is one really important thing you might want to remember, because some periodic tables even have three letter element symbols, so you really need to be careful about this. So yeah, so now we're going to learn about how we can use these, because we know what they are, we know how to gather their information. Now we're going to look at how to use this information. effectively. So this information, so as you can see before, as you can see, as you saw before, the groups, the those groups, those the top, the columns, yeah, those, they tell you the number of the number of electrons in the outer shell. So there's a nucleus. This is how the atomic structure is. We'll learn about that slightly later and go a bit more in depth. But right now I'm just going to tell you what it is. Summary of it. So there's going to be a nucleus in the middle. There's going to contain this nucleus. Around it, there are circular objects, okay? These are called the electron shells. The number of electron shells is defined by the period number. So the period number is, let's say, 6. The number of electron shells will also be 6. The group number, however, tells you the number of electrons in the outer shell. So in the outer shell, the number, if let's say magnesium, okay? Magnesium is in period 2, group 2. So period 2 tells us that it has two electron shells, and the group number tells us that it has 2 electrons in the outer shell. Okay. One thing to also remember is that the atomic mass that we discussed earlier, it tells you the number of neutrons. The atomic mass tells you the number of neutrons and protons. So remember that nucleus we were talking about earlier? It tells you the mass, the number of particles in that nucleus. The nucleus has a few parts. So it has two subatomic particles in it. It has the proton and the neutron. Okay. So those two, the number is shown by the atomic mass. The atomic number, however, tells you the number of electrons, or it tells you the number of protons. They're the same. In atoms, you will always find that the electron number is the exact same as the proton number. This keeps the element stable, and it stops it turning into an ion, which is a charged particle. Okay. This may be a bit to take in, but we will understand it a bit better when you get a bit older and get into these classes. So, electrons and elements and atoms. So now this will tell you what the element is. An element is a pure substance that is made of only one type of atom. Okay? An atom are these tiny particles that have a small nucleus in the center that we discussed before. So these are these tiny particles. Actually, one fun fact maybe, the word atom in Greek, in Latin, it means cannot be divided. The way scientists, like the way atoms were first early figured out, was by cutting things all the way until the atom was there. They weren't able to cut the electrons, the protons, and the neutrons out, so they left the atom as just that. Okay, so that's a fun fact if you want to know. Examples of elements, though, are oxygen with the element symbol of O, hydrogen with the element symbol of H, capital, iron with the element symbol Fe, You may be a bit confused. Why are all oxygen and hydrogen like similar to the element and iron is Fe? It doesn't make sense, does it? Well, this is mainly because when when the purity was first when these elements were first discovered, they were put into their Latin names. Like iron's Latin name is ferrous. Okay, so that's why it has an Fe, because ferrous starts with Fe. So yeah, you may also learn about this in DT, where ferrous metals, they are metals which contain iron in them. So that's a fun fact if anybody does want to know. And another example is carbon. It has the element symbol of C. Okay. So now we are going to discuss what metals and non-metals are. This is an important topic in all subjects. Well, in all STEM, in technology, in DT too. So metals, they are, you know how the periodic table that I showed you before, the metals are on the left hand side of the periodic table, also in the middle. Do you see that middle where there were no numbers in the middle? That is also part of the metals. And those metals, they have some properties. Like if you see here, metals are usually shiny and they conduct heat and electricity well. And they can be bent or stretched into different shapes. Okay, so metals are maybe not what you thought of as first, but they are very useful for some things. Oh, by the way, you may have thought of metals that they cannot be bent. A key way to think about this is, did you know that 24 karat gold can be bent by hand? It is not too difficult, because of how pure it is just gold, so it can be easily bent by hand. Okay. Non-metals, these are like, no, the name represents itself, they are found in the right hand side of the periodic table. There is one exception though, that's hydrogen. Hydrogen, even though it's a non-metal, is found on the metal side sometimes. It can also be found in the middle, like we did in our previous table. It was found in the middle. People think about it a lot because it has the properties of group of the period 1 elements, but then it just doesn't fit in with them because they're metals and it's a non-metal. So it's a very difficult discussion. Yeah. So and hydrogen, it is the most basic basic atom, which is an element possible to be made. Here's one proton, one electron. That's it. No neutron, which is very surprising. So non-metals, they are often dull. They can be brittle if they are solids, and many of them are gases at room temperature. Like say oxygen. Oxygen is a gas. We breathe it every day. It's in this room with me right now. Even probably with you're breathing it. Not probably, 100% with you. You're breathing it right now. There's even, let's say, carbon. Carbon is also sometimes found as a gas in the form of carbon dioxide. Okay. Hydrogen as well. Gas. Very important gas. So lots of non-metals can be found as gases. And one thing is that they do not conduct electricity or heat very well, or nowhere near to the capabilities of metals. Also, one thing to know with metals, is that they can be metallic. No, well, not in that way. They can be magnetic. Metals with iron in them or with some other properties can be magnetic. Okay, which is a really useful thing to know. Okay, so now we can move on to important groups. So some groups of the periodic table are really, really important, like group 1, which is called the alkali metals. They are soft metals, very reactive, and their reactivity goes increases as you go down the group. So the most bottom group 1 element is francium, and it is so unstable that it reacts with almost anything. So it's a very difficult element to sustain, and it cannot be sustained for very long, or a few seconds at max. So yeah. But group 7 elements, they're the complete opposite of group 1 elements. They are called the halogens. They are reactive nonmetals, unlike being reactive metals. And their reactivity decreases as you go down the group. The complete opposite of group 1. And there's also the group 0 that I told you was number 8. This is where we discuss what those are. These are called the noble gases. And these are most of the time found in their gas form. So these include helium, argon, neon, etc. So pretty important group. Pretty important group. Neon can be used to see the neon signs. Now you may know what neon come from. So yeah, pretty important group 0. And they are so unreactive. They react to almost anything because they have a full outer electron shell. That's why they call 0. The max outer electron shells is 8. Okay, and they have, because their group number is 8/0, they have 8 electrons, which makes them with a full outer electron shell. That's why we call them 0. If you also think about it, the 0 kind of looks like an O, so it represents like a circle. Fun fact. Now we can look at reactivity of the periodic table. Reactivity is a very important thing, as we just discussed before. It is very difficult to understand the reactivities of these groups can help create insane stuff. Like, have you ever tried maybe putting a bit of potassium into water? Pretty bad thing, because group 7 contains oxygen. Okay, that group 6 contains oxygen, and because water is H2O, that oxygen reacts vigorously with the potassium, creating a flame, which is really cool to look at, but kind of dangerous. You may also see this in school, so it is really fun though. Yeah. So now we discuss on to this topic: protons, neutrons, and electrons. So these were the subatomic particles we were talking about before. So protons are positively charged. Okay, think of it like magnets. You know, the positive charge, pretend it's like the north side, and the negative charge is like the south side. Okay, they attract each other, they repel each other. Think of it like that. Okay, because you can see in a magnet, the north side is mostly put as positive, and the south side is mostly put as negative. This relates to this. So protons are positively charged particles. Neutrons, these things in the middle, as you can see in the right, as you can see in this figure, they are these red dots. Okay, they have no charge at all. Okay, And the coolest thing about them is that if you do something to them, they actually emit an electron and then turn into a proton, which is really cool. And yeah, it shows you why they have that too. You may also be thinking one really big thing, that if these these protons are right next to other protons, how do they not repel each other? Because it's like a magnet. So how do they not repel each other? This is actually an A-level question, but what actually happens is there's this thing called gluon force which attaches them together. That's why they don't repel each other. Okay. So these are called subatomic particles. All these protons, neutrons, electrons, they're called subatomic particles. And we already figured out how to work them out. So the periodic table has a big history. Like the periodic table, did you know that it was first discovered by John Newlands with his discovery of the law of octaves? He kind of discovered that every eighth element had similar properties when arranged in atomic weight. This is slightly different to the periodic table we have today. Okay, but this guy called Dmitry Mendeleev, a Russian scientist, in 1869 created this periodic table, which was much different from the past, as it had gaps, which changed how everything was done, because those gaps, he thought that other elements would be made to fit those gaps, and they were. He was completely right. And he also got several of their properties right, regardless of the little amount of technology he had at the time, the little amount of information he had. This changed the periodic table like massively, and it influenced our periodic table today. Okay, but he was later followed by a scientist called Henry Moseley, who in 1913 made the periodic table ordered in atomic number instead of atomic mass. This fixed a lot of anomalies like the iodine tellurium swap. You may see this in old periodic table. So yeah, it's a pretty big thing. This was the last scientist who he fixed the periodic table to what we have today. This created the modern periodic table. In conclusion, the periodic table was a big step in the making of technology, because it allowed scientists to use. So instead of trying to figure out their own elements again and again, they just figured it out once and everybody got to know. So it was much easier. That concludes this video. Remember to check out the description. I have put the PowerPoint link here in the description. Also, you may see some exercises. I put them up in the last video if you want to check it out. So yeah, that finishes the video. Bye.